This video is about walking and teleporting on terrain. It is not about generating terrain. A quick Google or YouTube search will identify many resources for terrain generation. In the previous video, I introduced a method to divide a mesh into two parts: the floor, which you are allowed to walk on, and not floor, which you are not allowed to walk through. In this video, I am going to extend this method to terrain. So, if you haven't already watched my video number 9, please do so now. There are some caveats when dealing with terrain. Terrains can be large, so we may need to reduce the mesh, both to maintain runtime performance, but also to make the editing process practical. Terrains commonly exist in two formats. We need a workflow for both. I am going to use one example of each of these common formats. The first example is where the mesh is held as an OBJ file, in this example consisting of approximately 2,500 triangles. The second example uses a terrain resource which appears to have been created using Unity's built-in terrain editor. The terrain height is defined by a height map, where each pixel represents an individual height value. In this example, the height map is 4096 square, giving a total of nearly 17 million individual height values. Despite the different formats and mesh data size, the aim in both cases is the same: to generate our floor and not floor meshes. Once we have these, we will be able to walk and teleport around those parts of the terrain flagged as floor. I have downloaded both these assets. Let's install the mountain terrain. Go to Window, Package Manager. Click on Mountain Terrain and Import. Import. Close the Package Manager. In the project pane, go to Assets, Mountain Terrain, MISC, and drag Terrain 01 Low 2 into the hierarchy. Select the mesh, go to Textures, and drag in the textures to fill in the material. You can see that Terrain 01 Low 2 is an OBJ file. This defines the mesh we want to split into floor and not floor sections. However, this is a much larger and more complex mesh than those we worked with in the previous video. Manually splitting this would be a lot of effort. What we need is a tool which helps identify the relative slope of various parts of the mesh. The flatter the mesh, the more likely it is to be part of the floor, whereas the greater the slope of the mesh, the more likely it is to be part of not floor. Being an essentially lazy person, I created a tool to do just this. A link to download this tool is in the description below this video. Importing this OBJ file causes it to be displayed, in plan view, shaded in 4 colours. In order, from flattest to steepest, the colours are yellow, red, blue, green. I'm going to save this as terrain coloured. Now I go to Blender and import it. File, Import, Wavefront OBJ. Terrain coloured, Import. Now, you could edit this in Blender, but I prefer to edit in SketchUp, so I'm going to export it as Collada. File, Export, Collada, Terrain coloured, Export. Go to SketchUp, File, Import. I want to reduce the 4 colours here to just 2, for floor and not floor, which means I want to end up with just yellow for floor and green for not floor. Right-click, Explode. I think the vast majority of blue faces are not floor, so I'll use the colour picker on green, then I'll select a blue face, right-click, select all with same material. Then I can change all the blue to green in a single operation. There are a number of yellow and red faces which are fully surrounded by green, so these can be set green too. I'm aiming to create a roughly spiral path up the mountain, which means making some yellow green and, for a few isolated cases, making some green yellow. In order to save time in this video, here's one I prepared earlier. Select all, plug in front face to back face. This ensures that both sides of all faces are the same colour. I want to actually make this as two groups. Select yellow, all same material, edit, make group. Select green face, all the same material, and make group. I recommend saving this composite version as a SketchUp model in case you need to come back to it later to tweak it. File, Save As. Note that all pieces of the same colour are contiguous. If this is not possible, then non-contiguous pieces of the same colour should be formed into discrete groups. Finally, I need to save the green and yellow as separate models. Let's delete the green, explode, File, Export, 3D model. Name it yellow. Ctrl Z a couple of times to bring back the green. Delete the yellow. Explode, File, Export, 3D model. Name it green. And let's return to Unity. Let's look at how we structured the maze in the previous video. There was a top-level game object, underneath which was a numbered game object for each of the pieces, 0, 1, 2, and 3. Within that, there was the actual cave section, the mesh of the top, the mesh of the floor with an ignore player collision, a game object for teleport holding a second copy of the floor section with an ignore player collision. We need to reproduce that structure, so let's do that now. Create an empty game object which we'll call ground. Zero its position. Create a child game object which we'll call 0. And let's move our terrain to place it inside item 0. Now we need to import the green and yellow pieces as the floor and not floor. Note we have the same scale problem we had before, so we'll scale 0.0254. Let's import the yellow. Same scale problem. These are in place, of course, for the mesh, not for the rendering. Let's take the green, remove the mesh renderer, and add a mesh collider. The yellow, of course, has to be called floor. Remove the mesh renderer, add the mesh collider. These need to be placed under 0 as well. The floor needs the empty child, called ignore player collision. Now we need to add the teleport. Create an empty child, call it teleport, add a yellow to that, scale it, add a mesh collider, and add a teleport area. You can see the interference problem we had before, so go to teleport, set the height 0.1. That removes the interference problem. Once again, this is a floor piece, so it needs a child called ignore player collision. Now we need to add the scripts. To the ground itself, we add uneven ground. And to the individual piece, we add ground piece. This is the same as the original maze piece from the previous video, apart from changing the name to a more generic one. There is only one piece, so the high and low pieces that can be seen are both 0. Finally, I want to place the play area at the beginning of the spiral, so I need to set the position to -20, -15, and also, for some reason, The base of this is 2 meters up, so I need to lower it 2 meters to bring it down to the correct level. Let's play the game. Here we are, looking at the mountain. If I press the teleport button, you can see the spiral path I created. Follow the path. Up the hill. I can see the whole path. This means I could jump between rings of the spiral. Also, I can see through the mountain. This means the path needs to be split into sections, so you can only see the section you are on, and the corners immediately before and after. Looking at the hierarchy, there will need to be multiple numbered game objects underground. The terrain itself and the green no floor game object are both whole terrain, so they only need to exist under game object 0. But the floor and teleport game objects would be per path section. If you need to know how to do this, please refer back to my video number 9. If I walk towards an uphill slope, you can see the not floor collision works correctly, and I stay on the path. But if I walk towards a downhill slope, the not floor collision does not work, and I can leave the path. As I walk towards an uphill slope, the body collider collides with the not floor mesh. Whereas, as I walk towards the downhill slope, the body collider flies over the top of the not floor mesh. What I've done here is create a sloping lip at the edge of the path. I'll select all, paint green. Everything is now green, and export it, overwriting the existing green mesh. Now, as I walk towards the downhill slope, the body collider collides with the new uphill lip, and so I can no longer stray from the path. Now let's look at the other type of terrain. I've already downloaded this. Go to Window, Package Manager, 3D Realistic Terrain Free, Import, Import. Close the Package Manager. This terrain will be another piece of ground. Add an empty child underground and call it 1. In the project pane, go to Bad Raccoon, Terrains, Terrain A, and drag it into 1 in the hierarchy. If we double-click on this terrain, we can see it is much larger than the previous example. I'm going to make it so the player can explore this central plane of the terrain, i.e. the floor or yellow mesh, and the rest of it will be not floor, green mesh. But, unlike the previous terrain type, we don't have an OBJ mesh file to work with. We get round this problem by following the instructions here. In the project pane, go to Scripts, right-click, Create, C# script, call it Export Terrain. Double-click to edit the file. Go to this web page. The link is in the description below this video. Click on the Copy Raw Contents icon. Return to the editor, select all and paste, replacing the original file contents with those copied from the web page. Save the file. Return to Unity. Once the script compiles, you'll see this pop up. Select Yes. This will add a new tab to the menu named Terrain with a single option, Export to OBJ. In the hierarchy, select Terrain A and then select the new menu option, Export to OBJ. Select Format Quads and Resolution Full, then press Export. Note, this will be a large OBJ file and Unity would try to import it if it was saved under the Assets folder. I'm going to save it at the top level of the project folder, and I'm going to call it Terrain A Full. This will take some time, so I'm going to skip to the end. Now let's load this OBJ file into Blender. File, Import, Wavefront OBJ, Import. Note that this file is large, nearly ½ GB. Simply loading it into Blender takes many tens of seconds. Bring it into view. Because it's so far away, we need to change the end clipping. So press N, click on the View tab, and change the end to 5000. This mesh has over 4 million faces. Far too large for many tools to handle. Converting it directly to Collada and loading that into SketchUp version 8 takes, well, I gave up waiting after 8 hours. We need to do something to reduce the complexity of this mesh. In the top right pane, select the terrain. In the lower right pane, click on the Spanner tool and then add the Decimate tool. Enter a ratio of 0.025. Hit Return. Again, this takes some time. As you can see, this results in a face count of just over 200,000, so we can apply this. But we can still reduce this further. Remember, my target is to provide access to explore this plane. This will become the floor, the yellow mesh. The not floor, green mesh, is only there to prevent the player from leaving the permitted area, so we can delete huge parts of this mesh. Click here to show the vertices. Select a region, press Delete and Vertices. You may need to repeat. There is a lot to do here, so here's one I prepared earlier. Note that this has just over 60,000 faces, so we can save this, File, Export, Wavefront OBJ, Terrain A Decimated. Export. Now go to my Terrain Mesh tool and load the Terrain A Decimated file just created. Resave as Terrain A Coloured. Import this to Blender. File, Import, Wavefront OBJ, Terrain A Coloured. And export as Collada. File, Export, Collada, Terrain A Coloured. Let's load this into SketchUp. File, Import, Terrain A Coloured. This may take some time. Right-click, Explode. This also may take some time. Remember, our aim is to produce a contiguous yellow floor area surrounded by a contiguous green not floor band. This editing process can take some time, so here is one I prepared earlier. It would be possible to trim green even more, as it is only required to form an edge to the yellow floor area. However, this is sufficient to illustrate the principle. I have already saved this as a SketchUp file, Terrain A Trimmed. This allows me to return and make any tweaks as necessary. Now I need to export the separate green and yellow meshes. Delete the yellow, explode the green. File, Export, 3D Model, Terrain A Green. Ctrl-Z a couple of times, then delete the green, explode the yellow. File, Export, 3D Model, Terrain A Yellow. I have avoided saving files under the Assets folder so as to prevent Unity attempting to import the very large files which I have created. However, the yellow and green terrain files do need to be imported, so I'll copy them from their current location and place them in Assets, Bad Raccoon, 3D Realistic Terrain Free, Terrains. We now need to use the yellow and green mesh as colliders for our terrain. First, we remove the existing collider from the terrain. Drag Terrain A green under Game Object 1. Note we have the usual scale issue, so scale to 0.0254. Remove the mesh renderer and add a mesh collider. Drag Terrain A yellow under Game Object 1. Rename it Floor. Once again, correct the scale. Remove the mesh renderer and add a mesh collider. Add a child game object. Ignore PlayerCollision. Under Game Object 1, add an empty child game object and call it Teleport. Drag Terrain A yellow under Teleport. And again, correct the scale. Add a mesh collider and a teleport area. Add a child game object. Ignore PlayerCollision. If I set the Y position of teleport to 0.1, this removes most, but not all, of the interference with the terrain. For now, I'm going to leave it like this because I am demonstrating the principles. You could increase this value, although the larger this value, the more the teleport area will appear to float above the terrain. Under the One game object, we add the ground piece script and set the range low and high both to 1. As for the previous example, you could, of course, split the yellow floor mesh into multiple pieces to avoid being able to see through the objects. Finally, before we try running this, set the position of the play area to 703, 33.9, 373.8. This will place you nicely in the middle of the terrain. Let's run the game. Here we are in the middle of the plane. Let's teleport to the edge of the floor area. As we try to walk outside the floor area, we can see the play area moves to restrict our movement within the virtual world. As we walk downhill, our height automatically adjusts. Similarly, as we walk uphill. The explorable area of this terrain is huge. Terrains are useful, both as an area to explore and as a way to restrict which areas can be explored. The concepts covered in this video satisfy both these requirements. Don't forget that the not floor mesh must always present an uphill slope as you try to leave the floor mesh. It is likely you will want to divide the floor into multiple pieces, as I did for the maze in video number 9. To aid this, the script uneven ground now contains number of ground pieces to allow easy edit of the total number of pieces. Also, the variable names have been made more generic, replacing maze with ground, and comments have been improved. Apart from this, it is functionally the same as the version introduced in video number 9. The PlayerCollision script from video number 4 has been updated. Make sure you have the latest version. The slope colouring tool has default values for red, blue and green. 0.4 is 21.8 degrees, 0.55 is 28.8 degrees, and 1 is 45 degrees. You can, of course, change these, but I have found these values to be quite reasonable. Please look out for my next video.